So that's going to be the 31st. That's your very first day back. There will be a quiz. You will, however, be allowed to use your periodic table for the quiz. Okay. I will be available during Flex on Monday, March 31st to help you with questions. Also, I will be available at lunchtime to answer any questions. And if you have questions at the beginning of class, I'll be happy to go over anything at the beginning of class as well. Okay, so you can see that we have, oh, and I did want to point this out to you. There is one section, you'll notice it goes 3.1a, B. 3.1c is enriched. And we will watch it when we get back, so don't do it. Just don't do it. Okay? Just don't do it. We will watch it together when we get back because I think it's important for you, even if you don't ever care to look at it again, to have that conception of the atom as it truly is, as opposed to the little made-up Bohr models that we use so often. So you'll watch the videos and fill in the blanks and do the exercises, pages 1 to 29, except for 3.1c. In your, I haven't given you that in your data booklet. I'll need to make a copy of that for you. Finding numbers of subatomic particles. I will do that today. Okay, very cool. And you will be doing 3.2a and 3.2c. The reason you're not doing B and D is because those are extra practice. Should you choose to do them, that's totally fine. Okay, no problem if you want to do B and D, but you don't have to. Okay, and yes, it's a chunk of change. It's a chunk of work, but you guys are senior students in a senior academic elective that takes you places like, you know, universities and BCIT and all sorts of places like that. So you do want to, you know, develop habits of being able to do work independently. Okay, and just to make you happy, there's a little, you know, flowers at the bottom. You can color them in if you like to. All right. Now, what will the quiz be like? The quiz will be like, there will be a chart question. Okay, so like on pages 34, 37, 40, and 52. Is there anyone in here who was in my grade 9 class? Zenny, you were in my grade 9 class. It'll look just like your grade 9 quiz, which I'm sure you remember perfectly. Okay. There will be Bohr model atom questions asking you to draw the Bohr model and name it, including naming isotopes, which includes the mass number, which is the protons plus the neutrons. There will be Bohr models of ions. And for anions, you need to change the ending to -ide. And you should know the difference between atomic mass and mass number. And this just gives you a little bit more details on it, okay? Everything gets walked through for you, though, all right? So we're good. Okay, that's it. There we are. Okay? And like I said, you get to ask questions when we get back. And if you ask questions for all the first period back, then we write the test on the quiz on day 2. Back from holiday. Is good?
Yeah, ask a lot of questions.
Ask a lot of questions and you'll be golden. Thank you. All right, but in the meantime, we are going to continue on with Unit 4. All right, so back to Unit 4. And we want to go to in the past, I have done this very slowly, and I feel like we can go faster because you are no longer COVID babies who like missed a year of everything, right? Or maybe you did miss a year of everything, but it was back in elementary school when you weren't learning about chemical formulas, so it was okay. All right, so We are on page 10. So previously we went from the name to the, from the name to the formula, yes. Now we're going to go from the formula to the name. And we're going to start with the very easiest of them, okay? These are our binary ionic compounds. How many elements do you think these are made of? 2 elements. What are those 2 elements if they are ionic? Cation?
Oh, they're metal and non-metal.
Yep, the cation is a metal, and the anion is a non-metal. And if you're just finishing up your rewrite of the quiz, we are on page 10. And there's a reason I write it in that order. The cation always comes first, the anion always comes second. And you should be familiar with that from writing the formulas, yes? Okay. And we have our crystal lattice here. This is the type of compound we have. And you can see that perhaps, I don't know how many ions are in this crystal. Maybe there's 97 sodiums and 97 chlorides in that particular crystal. Is that how we write the formula? No, we simplify it to NaCl, okay? It doesn't matter if I have 1,000,000 sodiums and 1,000,000 chlorides, I always simplify ionic compounds to their formula unit, like the actual form. The formula is the formula of the formula unit. It's the simplest form, okay? Now, how do these things form? We are showing only the valence electrons. Does anyone remember what a valence electron is? It's an electron on the outermost shell. And we should also write down that the valence shell is the outer shell. That's just a little help for Unit 3 because you'll need that for the stuff you do over the break. So we're showing only the outer shell. Sodium has 1 electron in its outer shell. Is that stable? No. If you recall, what type of shell do atoms like? Atoms are stable when their shells are full. Outer shell is full. So basically, in order to form a compound, metals will empty their shell, non-metals will take electrons, okay? And if they empty their shell, what that means is that their electron Na loses an electron. Yes? And if it loses an electron, it becomes Na plus. Yes? So now we have Na plus. Chloride, remember, 8 electrons is a full shell and it's got an empty spot right there. So chloride gains an electron. So the metal has emptied its shell. The nonmetal has filled its shell. And when I say their shell, I mean their valence shell. Okay? And because chloride got one extra electron, it is no longer Cl0, it is now Cl negative. So Cl goes from being Cl neutral, Na goes from being Na neutral into Na plus and Cl minus, okay? And how do we name these? Well, this is pretty easy because we already know how to do this. The cation's name is just the cation's name. It just doesn't change. So sodium stays sodium, calcium stays calcium, aluminum stays aluminum. Easy peasy. What happens to the name of the anion? Anion's name takes the ending "ide." Okay? And just so we're clear, you'll always have one syllable plus "ide." Okay? There are a couple of exceptions to that, but I'm not even going to mention them because they're not very important. And I want you to get that in your head, that one syllable plus "ide." So chlorine becomes, we get rid of the "ene" and it becomes chloride. Fluorine becomes fluoride. And I'd like you to notice that fluorine is spelled UO, not OU. And I will give you a half a mark off for that because it is written on your periodic table. All you have to do is copy it. And that is the most common spelling mistake ever. Not fluoride. You're not using flour. You're using fluorine. Fluorine. Okay? Now, remember what we said about having one syllable plus the "ide." So oxygen, we have three syllables, right? We have ox, I, gen, right? Three syllables. So we don't call it oxygen. We just use the first syllable and it becomes oxide. Make sense? Okay. So anything with three syllables, you have to say we have nitro, gen. So we only use the first syllable and we say not nitrogide, not oxygen, it's just nitride. So every anion will have two syllables. Oxide, nitride. Yeah? So not oxygen, not three, just two syllables. Okay? Same thing with phosphorus. Phosp or us. We just use the first syllable, phosphide, not phosphoride. Okay, not phosphoride, just phosphide. Amber alert. Okay, well, they're not in this classroom, so, all right. Okay, I mean, it's important, but there's nothing I can do about it right now, so there we go. All right, phosphide. Hydrogen does not become hydrogide because we have hydra, O, gen. So just the first syllable, hydride. Okay? So that's the only thing that's like tricky about this at all. We're not even going to spend any time doing this. The only thing, well, we will in a few minutes, but I want to teach you something else and then we'll come back to it, okay? The numbers don't matter. Okay, the numbers do not matter. I don't care that there's a 3 here. It's still just potassium. No numbers, no Roman numerals yet. We'll learn about those later, how to figure them out. Okay? The numbers don't matter for the name. So if I had BA3 and 2, the 3 and the 2 don't matter. I just say, what's the name of BA? BA is barium. And the N is nitride. Do you see any dis or tris? Ionic compounds do not use prefixes, okay? No prefixes on ionic compounds. Okay? Is that easy enough? Okay. So those are your ionic compounds, and we're also going to take a look at our covalent compounds. And this is on page 12. So if you remember ionic compounds, no prefix. Covalent compounds, yes, prefixes. Remind your partner, how can you tell if a compound is ionic? Metal or ammonium, which is NH4+. It starts with. So that's an ionic compound, and we don't use any prefixes. So that's like the previous one. So when you go back and you do 4.1a, you will not be using prefixes. When you go to 4.1b and we're looking at covalent compounds, yes, we have prefixes. Covalent compounds, how do we know we have a covalent compound? 2 nonmetals. And so we say, yes, prefixes. Again, these are binary, so they are made from 2 elements. And if you remember, in our last one, we had, in the ionic compound, the metal gave electrons away, the nonmetal took electrons, the metal ended up with a positive charge, the nonmetal ended up with a negative charge. We then have an attraction between the negative and the positive, okay? That's not how covalent bonds work. Covalent bonds form when elements do what with their electrons? Share. What does that look like? Well, here is, again, this is only I guess it's showing the valence shell in the other one. Here's hydrogen. It has 1 electron. How many does it take to fill the first shell? First shell needs 2 electrons. And oxygen's outer shell is the second shell. How many electrons does the second shell need?
8.
It needs 8 electrons. So if we count up oxygen, oxygen has 1, 2, 3, 4, 5, 6. So oxygen has 6 electrons. hydrogen has 1 electron. But hydrogen doesn't just want 1, it wants 2. So what could be nicer than hydrogen? Oxygen can help hydrogen out by sharing, okay? So now we have shared electrons. So oxygen has shared 1 with hydrogen, so now hydrogen has 2 electrons. Yay! Happy little hydrogen. Metals and metals bond with each other, but in a very different way. Okay, and we'll talk about that later in the course, but not right now because it'll just confuse things. Okay? Non-metal, and then we have our other hydrogen, which also says, I would like to have 1 more electron here. So again, these guys are going to share. And so now we have our shared electrons. And if you're wondering what's sticking these things together, what charge is the nucleus of oxygen? What charge is any nucleus? Okay. In the nucleus, what are the particles in the nucleus? Protons and neutrons. What charge are protons? Positive. P for proton, P for positive. Neutrons are neutral, which means their charge is 0. Okay, neutral means 0. So if you have positive things and neutral things, what's the overall charge? Positive. Okay, so the nucleus is positive. And that's for oxygen and also for hydrogen. All nuclei are positive. What charge are electrons?
Negative.
Electrons are negative. And so what we have now is we have negative charges in between positive charges. So if I put a positive here, and I put 2 negatives here, and I put a positive here, is that going to stick nicely? What does positive do to negative? What does positive do to negative? Attract. So are these things attracted? Is that a good arrangement? Yes. So this would be the nuclei. Nuclei is the plural of nucleus, and these are the shared electrons. And it's because you've got this positive nucleus and positive nucleus. Normally those two things would push each other apart, but what do we put in between them? What goes in between the 2 positive nuclei? Negative electrons, and those negative electrons act like the glue that holds it together. Now, hydrogen is still neutral. Oxygen is still neutral. Hydrogen is still neutral. Oxygen is still neutral. Nobody has a charge, okay? Covalent compounds do not have charged ions. They just have neutral atoms sharing electrons. Would it be possible for H2O to be H4O2? Is that water? No. H4O2 is not water. H2O is water. Yes? And there's no way we could have a molecule that's bigger than, we can't have like O, O, H, 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 H. There's no such molecule. Okay? No such thing. Okay? Does not exist. So this is why we don't use the simplest formula for molecules, because covalent compounds, when we give you the number of atoms in that molecule, that is the exact number of molecules in that molecule. Okay, so if I gave you N2O4. N2O4 does exist, and it looks like this. N, O, 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 O. Okay, that's N2O4. We would never simplify that into NO2. And the reason is that this is a clear, colorless gas. If we break it apart, which happens if we heat it, we get NOO and NOO. And this is a brown gas. This has no scent. This is stinky. Not to put too fine a point on it, it is stinky. Is N2O4 the same thing as NO2? Nope, they are different things. They have different properties. That's why I could not simplify this formula.
Is it NO2 nitrite?
No. Nitrite is NO2 minus.
Oh.
Yeah, it's got an extra electron. Not mine. No.
Okay, it was given to us.
Oh. Okay, so are we good with that? That's why we don't simplify molecular compounds. But remember back in our ionic compound, if we have a large crystal of sodium chloride, does it taste salty? Yes. If you have a small crystal of sodium chloride, does it taste salty? Yes. So that means that no matter how big or how small the crystal of sodium chloride is, it has the same properties, which is why we simplify our ionic compounds and we do not simplify our covalent compounds. When you simplify a covalent compound, it becomes a different compound. Yeah? It becomes something else altogether. Not a huge deal. If you don't understand that, you can just remember, simplify ionic compounds, don't simplify covalent compounds. If you understand it, that's fabulous, but you don't have to. Okay? Now, back to the actual matter here. Okay, so these guys share electrons in order to get a full shell of 8 or 2 electrons for hydrogen, which is a very stable arrangement for the electrons. Between what types of elements do covalent bonds form? Non-metal, non-metal. When elements bond covalently, they mostly form little clusters of atoms bonded covalently. What do we call those? Molecules. There are 2 names for compounds made only of nonmetals. What are those 2 names? We can call them something compounds, or we can call them covalent, or we can call them molecular. And this is something you should already know. When the atoms of a molecule are all the same, we have a molecule of an element. And we won't worry about naming those because those are just the names of the element. That's hydrogen, that's oxygen, that's nitrogen, easy peasy, yes? But when there are different types of atoms in a molecule, we have a molecule of a compound. And all of this just gets us to the fact that we're going to be naming covalent compounds. So, super similar to ionic compounds. Remember, if we have an ionic compound, we name the first element calcium. F is fluorine, but we change it to fluoride. In an ionic compound, we name our first element. This one is copper. Copper is in the red zone. So it needs a Roman numeral. I'll show you how to find those later. For now, I'll just tell you that's a Roman numeral 2. Copper 2, fluoride. Now, covalent, it is very, very similar. Carbon, dioxide. What's staying the same here? The first name does not change its ending. The second name changes its ending. Okay? First name, no-ide. Second name, ide. So that's very much exactly like ionic compounds, right? No-ide, ide. Now we look at things that are different. Remember with the ionic compounds, were there any prefixes? No prefix. Ionic. Copper, ionic, because it starts with a metal. No prefix. But the moment it becomes covalent, yes, prefix. Okay, so we have the di and we have the hexa. Yes, prefix. And you might notice that the carbon is missing one, but we'll talk about that in a moment. So far, so good? So ionic, no prefixes. Covalent, yes, prefixes. First name, no-ide. Second name, ide. Okay, then I go blah, 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 blah. Okay, and then we go into how do you name them? If we have one of the first element, no prefix. This is a weird little, this is the weird bit. This is the only part of covalent compounds that makes it kind of like icky, okay? One of the first element, no prefix. So this is just going to be silicon. And now we know that we have 2 oxygen atoms. What is the prefix for 2? Di. So it's dioxide. Yes? Are we worried about balancing charges? No, because there are no charges. They are covalently bonded. Now, remember, if we have one of the first element, there's no prefix. But what if we have one of the second element? Mono. So we use mono on the second word, but not on the first word. Mono on the second word, but not on the first word. Everybody, including Ethan, who's on his phone, mono on the second word, but not on the first word. Okay? Mono on the first word, second word, mono on the second word, mono on the second word, and no mono on the first word. Okay. I have not yet thought of a song to go with all our metric prefixes. If anyone comes up with one over break and it's catchy enough that we could learn from it, I will give you a bonus mark on your next test. Okay? Something to think about. Little creative juices flowing.
Wait, metric prefixes or these?
Not the metric prefixes, the mono, di, tri, tetra, blah, 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 blah. I tried. Tried putting it to Jingle Bells and Mary Had a Little Lamb, and I'm like, none of these work, so anyway, that doesn't work. So I will put it in your guys' very capable and creative hands. All right. Iodine. 4 chlorines. This is on the first word. We have one of the first words, so there's no mono. No mono on the first word. So it's just iodine. Okay, so in our previous example, sorry, I got distracted by songs and such, like no mono. No mono on first, mono on second. Tetra is 4, so you would say tetrachloride because you have 4 chlorides. Now, sometimes people think if there's no mono on the first word, I never put a prefix on the first word, but you do unless it's mono. So if it's di, stick that prefix on there. It's only mono that we leave off, okay, and only on the first word. So 2 phosphorus, 5 oxygen, diphosphorus. Diphosphorus, die! Like the scummy dog you are. Pentoxide. Sorry. Now, you might remember that 5, what's the prefix for 5? Penta. Do you see an A there?
You dropped the vowel.
We don't drop a vowel because we don't drop I's.
No, you dropped.
We drop O's and A's and only before oxide.
Oh.
Okay?
Okay.
So we drop O's and A's.
Oh.
So rather than mono-oxide, we just do mon-oxide. Rather than tetraoxide, it becomes tetroxide. Okay? 2 nitrogens, dinitrogen. 1 sulfur, monosulfide, because it's the second word, we need that mono. 3 phosphorus, triphosphorus, 5 sulfur, pentasulfide. Okay? And then the next page, I think it just kind of gives you more examples. Blah-de-blah-de-blah. All right. Oh, yada, yada, yada. Blah, blah, blah. There's a lot of stuff that just says what I've already told you. So you can, for homework, you can do page 16 and page 11. Check in with your, especially for page 16, check in with your answer key frequently and pay attention to things like dropping the A. So pay attention to the spelling. Should I give you every other question on page 16? Every question? Let's give you every question. Okay, fine. No, it's not that long. You might even be able to finish like a whole ton of it in the next 5 minutes. You'll be able to finish a shocking amount of at least page 11 in the next 5 minutes. You'll be like, whoa, it's all gone, it's all done. Remember page 11, no prefixes. Page 16, prefixes.
Wait, Mr. Dragon.
Yes.
Organic. Organic?
Organic, I can have it for tomorrow.
Oh, yeah.
Yeah, sure. Yeah. I'll do that.
Okay, I'll try my best to find some. I also just don't.
Yeah.
Formula stuff. Just the hardest part is you can find a photo of it. I mean, it's I still figure out where it is.
Did everybody get the new book for the spring break homework? Yes.
Oh, yeah. I think they're gonna take it all that. I'm not gonna do that. Get it all over. No, it's all building. Yeah, but this.
Brennan, I got your quiz. Yay.
Miss May,
Hi.
does Friday end at 2?
No,
No.
Friday's a normal day. Yeah. Losing my flipping mind. Losing me flipping mind. How can I possibly have lost it? Oh, there it is. Okay. Phew. Bring Kusei. Yeah. Dylan. There you go.
No, you're not.
Brandon, I think I'm marking correct. You just started. Where did you just started? I wrote the same thing too. No, not you. What did I do?
Yeah, when they go, that's okay. Oh, I was thinking, thanks, Mom. Yeah.
I swear that I know. Why can I do difficult things but not me? Oh, you put it on the back. Oh, yeah. Jacob. John. Okay. Okay. Maya.
Spell my name.
Yes, I did.
Oh.
You didn't even write this quiz. You just copied the last one. Those are the answers to the last quiz, not this quiz.
Oh, I'm sorry.
Yeah, so you were just copying them from somebody. That makes me very unhappy because
No,
I've
no,
been
no,
yes.
I thought it's the same one, so I just take it down from mine.
Okay, okay. So you can write this again next day. Okay?
Yeah.
Okay.
I thought it's like the same one, so I
okay.
just.
Okay. Yeah. Anywho, yeah, different one. I'll give you another copy next day. Okay?
Thank you.
Yeah. Jade. Six. Andy is away.
I moved it all down to.
Dude, I don't want.
Today is Thursday. I don't have anything on Thursday evenings. It makes me so happy. Have a good evening. Means I can go home and mark your guys' tests. Sure? It's all good.
Oh,
No worries. Don't worry. I got it.
thank you.
Hi.
Can I leave this with you? I think it was. Yeah.